Next topic is the dimensionless parameter for turbo machine, okay, including pump and turbine. For design, the size of the vane on and flow through the turbo machine. Main variables are delta P, Q, W, and N. So delta P is the pressure increase produced by the pump. Q discharge. W is the power. So we can write equation of power like this. Power supply for the pump is equal to rho Q. You learn from the hydraulics. Rho GQ and head divided by efficiency. Okay, so nu is efficiency and speed of rotor, and d diameter, rho density of fluid. And we can classify the variable into the independent variable and dependent variable, okay, based on different two types of the variable. And from this, how can identify the head power supply is equal to rho GQH. This is the main parameter is head pump. So this is a head pump. It's from the difference of the hydraulic gate line between before the pump and after the pump. And we can prove that about the, you will learn from the basic knowledge about the potential energy is mgh. Okay, the unit is joule. In this case, we convert from mass, so we can use the density times Q is volume per area to volume per time to mass per time, and G and HP. Okay, so we got the joule per sec already now. So finally we can got that this equation can prove that rho G, okay, is actually is a potential energy. And if we start to write equation, we can start to write the energy equation from point 1 and point 2. Maybe put Bernoulli. For Z1 plus the, no, I have to take at the elevation at the Z1, subtract head loss at the part 1 and plus the HP equal to Z2 plus the head loss at the by 2. So actually we can prove that H pump is equal to the difference of the elevation head and plus the head loss. Now is equal to delta Z plus the summation of friction loss and plus the summation of the minor loss. Okay, the next topic is the type of the pump. We can classify into main categories. The first we call the positive displacement pump, or we call pump chuck in Thai. It's like the it's a and the second part is we call rotodynamics or kinetics pump. Okay. So this for the first positive displacement pump is deliver a quantity of water with each revolution of the pump rotor, such as the piston. They use this piston or cylinder. We call reciprocating pump for the first type of the pump, and the second type rotodynamic pump add energy to the water by the accelerating it through the action of the rotating impeller. There are three types of the rotodynamics pump. The first is we call the radius the radius flow. In this case, it's the flow is like this. The movement of the flow is no, not this one. This one. The first type is this one. If you call radial flow, flow is parallel to the radial flow. The first is okay. Okay. That is radial flow. The flow is okay along the radius. Okay, and the second part we call the axial flow. This means the flow is parallel to the axis, and the third one is the mixed flow. The flow is in between radial and axis, radial and axial flow. Okay, that is a three type of the of the pump, and the other classification we classify based on the objective of the using. For example, fire hose pump, air pump, or groundwater pump, and wastewater pump. Okay. for radial flow pump, we call it, the common name is like centrifugal pump. In this case, water enters to the pump at the eye of impeller, okay, or the center of the pump, and centrifugal through the through vein to outside of the impeller, okay. And mechanical energy is transformed from the engine or electric motor through the vein, and vein push the surrounding water. Okay. You can look at this figure. For this is this is the vein, okay, and this radial flow, and you can more clearly in the next figure. Okay. See that this is the eye of impeller. Okay, the point that the water enter to the pump. Okay, and afterward the vein is push the water to the on the radius direction. Okay, okay, and to the casing and flow out from the pumps. Okay, you can go there to explain and explain more from the lecture. Also, that we call the centrifugal action. The value of the centrifugal the value of the centrifugal pump force increase. Force increase with the increase of radius. Okay, in the closer container. So pressure at the eye of mirror is the vacuum, and water is sucked into the pump, and water is pushed out along the circumference of the impeller and pump casing, and collect water with the high pressure. Water flow out at the discharge opening. Okay, that is this discharge opening from this is correction of the flow. Okay. And again, and the other figure is this figure is a centrifugal pump. This for the axial flow pump. Then this show the mechanism for the centrifugal pump. Okay, there is many components: is foot valve, and reducer, and check valve, and gate valve. Okay, and this figure shows the axial flow pump. Okay, this impeller in the bottom, has motor on the top, and flow parallel to the axis. Okay. And for the mixed flow pump, okay, the outflow have both the radial and axial component. Okay.